Hi, this is Felix. We are discussing Standard 12th Physics, Unit 1 Electrostatics. In this, a very important topic, one of the 5-mark question, electric field due to an electric dipole at a point on the equatorial line. So first of all, we have to consider a equatorial plane. Okay, so this is the equatorial plane. Either side of the equatorial plane we are considering there are two charges, one is the minus q and another one is the plus q, and both are situated at a and b respectively. The midpoint of the dipole will be denoted in terms of O, and this will be denoted in the midpoint of the uh, equatorial plane. Now from the midpoint, each charge placed at a distance of a. Now we have to consider an external point in equatorial line from its midpoint at a distance of r, and this will be denoted in terms of c. Now with respect to point C, we have to consider the electric field intensity with respect to the positive charge and with respect to the negative charge. So with respect to the positive charge, electric lines of force will be pointing outward direction. So with respect to point C, it is acting along this direction. And with respect to the negative charge, the electric field will be acting towards the negative charge. So it is acting along CA direction. Now with respect to point C, the resultant electric field or the total electric field is acting along this direction, so which means negative dipole moment direction, opposite to the dipole moment. It is acting dipole moment. So now we have to see everything in detail in this derivation. For the understanding I am explaining step by step, but for the exam point of view you just go through the book what is given. So first of all, we have to see the electric field intensity with respect to the positive charge, and the formula is nothing but 1 divided by 4 pi epsilon naught q divided by b square, okay, along BC. So it is acting BC direction, along BC direction. Next, with respect to the negative charge, the electric field which is associated at C is denoted in terms of E minus vector. So E minus vector, which is equal to 1 divided by 4 pi epsilon naught q divided by AC square along CA. It is acting along CA direction. Right. Now in this two equation, we have to find out what is BC square, what is AC square, for which we have to take this right angle triangle. If it is a right angle triangle, two sides we know, the another side we do not know. So finding this we have to use Pythagoras theorem. Okay, so the right angle triangle COB. Okay, here we have to use Pythagoras theorem. So one side is R, another side is A. So now BC square, which is equal to CO square plus OB square. Okay, BC square, which is equal to CO square plus OB square. So BC square we may not know what is that, so we have to keep it as it is, which is equal to what is CO, it is nothing but R, so R square plus A square. So similarly the same way we have to see the other side, COA. So here also we know this two value, we may not know what is the value of AC. So AC square, which is equal to CO square plus OA square, which is equal to CO is nothing but R and OA is nothing but A. So finally we will get AC square, which is equal to R squared plus A square. Now this value we have to substitute. Okay, this value we have to substitute in this above equation. So here we have to use these two values, what is BC square, what is AC square. These two values we have to substitute here. Then you will get a E plus vector, which is equal to 1 divided by 4 pi epsilon naught q divided by r squared plus a square along BC, and negative charge with respect to the negative charge E minus vector, which is equal to 1 divided by 4 pi epsilon naught q divided by r squared plus a square along CA. So by seeing these two, both are acting in a different directions. Hence, the total electric field, okay, we have to calculate. Since it is acting in the different directions, we have to resolve into two compound. So we have to resolve into two compound. One is parallel to the dipole axis, and another one perpendicular to it. So here we are resolving into two compound. One is a vertical compound and another one is a horizontal compound. With respect to the positive charge, the resultant electric field will be acting along this direction. With respect to the negative charge, the resultant electric field will be acting along this direction. So now, with respect to this electric field, the horizontal compound will be represented, or the parallel compound will be represented, the modulus of E vector into cos theta. Vertical compound or perpendicular compound will be represented in terms of modulus of E plus vector into sin theta. The same way, with respect to modulus of E minus vector will be divided into two compound. One is the horizontal. The horizontal compound will be represented in terms of modulus of E minus vector cos theta. The vertical compound will be denoted modulus of E minus vector into sin theta. Now, as we know that the magnitude of these two values, because these values are similar in both equations, so that modulus of E vector and modulus of E minus vector, E plus vector and E minus vector, both are equal in magnitude and acting in the opposite direction. So these two will be get cancel each other. But here horizontal compound is moving in the same direction. Both the positive charge as well as the negative charge is horizontal compound is moving in the same direction. Hence we have to gets added up. Okay. Now we have to calculate the total electric field is acting along negative x-axis direction. This is nothing but the negative x-axis direction. Therefore, the direction of dipole moment is taken towards negative charge. So now the dipole moment will be acting towards the negative charge. But actually, the direction of dipole moment is always negative charge to the positive charge. But here we are taking in terms of negative dipole moment is acting along this direction. Okay, so we are representing minus p vector in the diagram. We are representing the dipole moment will be represented like this, minus p vector, and it is acting towards negative terminal. But actually, what is the direction of the dipole moment? It is acting always negative charge to the positive charge. Now the total electric field E total vector, which is equal to modulus of E plus vector cos theta minus of P cap plus modulus of E minus vector cos theta minus of P cap. Okay, here modulus of E plus vector and E minus vector are same. So that value we have represented here, 1 divided by 4 pi epsilon naught q divided by r squared plus a square. Now we have to substitute in this above equation. So these values we have to substitute in the above equation and then we have to simplify. So therefore E total, which is equal to E vector total, which is equal to, what is the value of modulus of E? So we have to write, so this minus term we have to bring it front. So minus 1 divided by 4 pi epsilon naught, then q divided by r squared plus a square into cos theta, okay, into p cap plus, and this minus we have to bring it in front, so minus of 1 divided by 4 pi epsilon naught q divided by r squared plus a square into cos theta p cap. And next step, this minus we have to multiply these two. Minus into plus is nothing but minus, so we have to multiply, and the common terms we have to bring it together. So which means minus 1 divided by 4 pi epsilon naught q divided by r squared plus a square cos theta p cap minus 1 divided by 4 pi epsilon naught q divided by r squared plus a square cos theta p cap. So now all the terms are similar, so that we have to take it commonly. So minus 1 divided by 4 pi epsilon naught q divided by r squared plus a square cos theta p cap. Everything we have taken. So what about the remaining 1? And here also 1, so 1 plus 1, so you will get 2. So now minus 2q cos theta p cap whole divided by 4 pi epsilon naught r squared plus a square. Next we have to see the value of cos theta. Okay, so cos theta, which is equal to adjacent divided by hypotenuse. So this is the formula to find the value of the cos theta. So how we can find the cos theta value, as we have a diagram. So in this diagram you have to take any one of the triangle, whether it may be a AOC or COB. So you have to take any one of the angle, and here we are representing the angle theta. So with respect to this theta we have to apply the cos function. So adjacent divided by hypotenuse, so AO divided by AC. Okay, so now here we have to substitute the value. Okay, so in this formula here we are representing the value cos theta, which is equal to, okay, so cos theta, which is equal to adjacent divided by hypotenuse, which is equal to adjacent, as I said already, it is nothing but A divided by AC. As we know the value of AC square, which is equal to r squared plus a square, and we have to take a square root on both sides, which means AC, which is equal to square root of r squared plus a square, and this value we have to substitute here, and this value we have to substitute in this above equation instead of this cos theta. So the above equation is rewritten once again: minus 2q divided by 4 pi epsilon naught r squared plus a square. Now here this is nothing but cos theta value, a divided by, we have to write square root of r squared plus a square, and the equivalent value we have represented, that square root will be represented in terms of power 1 by 2. So a divided by r squared plus a squared power 1 by 2 into p cap. Now there is one of the rule we have in max. So when you are multiplying two function, if base is same, we have to add the powers. So now here base is same, so that we have to add the powers. So here the power is 1 and here 1 by 2. If you take the LCM, it is nothing but 3 by 2. Okay, so now this value we have to substitute here, and the numerator is nothing but minus 2qa p cap, okay, divided by 4 pi epsilon naught r squared plus a square whole power 3 by 2. If r is very large compared to a, then a square is neglected. If a square is neglected, remaining will have only the r. So r squared into 3 by 2. So 2 will be get cancelled. Finally you will get r cube. Now we have to substitute in this equation. Finally you will get the total electric field. So the total electric field with respect to the equatorial plane, which is equal to minus 1 divided by 4 pi epsilon naught p vector divided by r cube. What is that p vector? P vector is nothing but dipole moment. What is the value of dipole moment? Since the p vector, which is equal to 2 a q into p cap, as we have already introduced in the axial line the same way. Thank you.